Hi friends, welcome back to Sea Level Physics. Myself Srinivas B, known to be BS Rao. In the previous lecture, we have discussed introduction of vectors and types of vectors. In this video, I am going to discuss displacement vector, position vector in terms of Cartesian coordinates. Okay, let us see. What is meant by position vector? Position vector in the sense, by the name itself, it's a vector which describes position of particle or an event with reference to a fixed origin. Okay. Now what is meant by displacement vector? Displacement vector in the sense, a directed line segment drawn from the initial position to the final position when a particle is under motion is known as its a displacement vector. Okay. Let us see one by one position vector and displacement vector. Okay, for that I am going to draw Cartesian coordinate axis. Okay, see, this is x axis, this is y axis, this is z axis. As I told you, unit vector along x axis, that is I cap, unit vector along y axis, that is j cap, unit vector along z axis, that is k cap. Okay, all the three mutually perpendicular axes, they meet together at this point, common point. This is what our fixed reference point O. This is what O, whose coordinates are 0, 0, 0, 0, 0, 0. Okay, suppose a particle is situated somewhere here at point P, at point P with coordinates x1, y1, z1, x1, y1, z1 with respect to O, with respect to O. So the time, let it be t1. So P is the position of the particle at any instant t1. Okay, with position coordinates x, y, z. So these coordinates are with respect to fixed origin O. At some other instant t2, the same particle is situated somewhere here at point Q with the position coordinates x2, y2 and z2. x2, y2, z2. So at any instant t1, P is the position of the particle. At some other instant t2, Q be the position of the particle. Okay. Now how to write position vectors? Simply by drawing a line segment from reference point O to given point P. Suppose if I draw a position vector like that, OP bar is the position vector. Let it be R1 bar. R1 bar. How to write here means simply by a directed line segment drawn from fixed origin to the position of the particle. Now this is the position of the position vector of the particle at instant t1. At some other instant t2, what is the position vector? Means take one more line segment drawn from the fixed origin to the reference point Q. Means a line segment drawn from fixed point O to the position of the particle Q. Okay, this is R2 bar. R2 bar. So R1 is the initial position vector at any instant t1, and R2 bar is the final position vector and at some other instant t2. Now what is the angle made by R1 bar with reference axis x-axis? This is what reference axis. Reference axis. I am taking x-axis as the reference axis. So angle made by R1 bar with x-axis, let it be theta 1. Okay, now what is the angle made by R2 bar with x-axis? Let it be theta 2. Okay, now in a time interval t2 minus t1. Now here time is t1, here time is t2. Now what is the time interval between p and q means t2 minus t1. In that time interval t2 minus t1, particle has displaced from p to q. So draw one more line segment from position p to position q like that. Let be displacement vector in a time interval t2 minus t1. So r1 means r1 equal to, how to write initial position vector in terms of Cartesian coordinates means simply x coordinate into I cap plus y coordinate into j cap plus z coordinate into k cap. So x1 into I cap plus y1 into j cap plus z1 into k cap. So this is what initial position vector. Initial position vector. Now coming to final position vector. R2 bar. R2 bar means what are the coordinates for Q? X2, Y2, Z2. Now in terms of position vector, X2 into I cap plus Y2 into J cap plus Z2 into K cap. So X2 into I cap plus Y2 into J cap plus Z2 into K cap. This is what final position vector. Final position vector. Now coming to S bar. S bar is nothing but PQ bar. So PQ bar equal to S bar, that is nothing but displacement vector. Displacement vector. So here we have three vectors. One is initial position vector at an instant t1. Another one is final position vector at some other instant t2, and displacement vector in a time interval t2 minus t1. So that is how here we have three kinds of vectors. So initial position vector, final position vector, and displacement vector. Now what is the angle made by displacement vector with the x-axis means, suppose this is the x-axis. Now should this x-axis parallel to itself somewhere here. So this is also x-axis. Why? Because these two parallel to each other. So let it be theta. So angle made by R1 bar with x-axis theta 1, by R2 bar with x-axis theta 2, by S bar with x-axis theta. So that is how we have three angles made by three vectors. Okay. Now here particle has taken a path O to P and again from P to Q. Now what is the ultimate position or ultimate destiny of the particle means Q. Okay. If a particle takes another path from O to Q also, it can reach final position Q. So that is the reason why what I am saying means path OP plus PQ is equal to path OQ. Path OP plus PQ equal to path OQ. So if particle directly reaches from O to Q also, it can reach Q. Okay, but here particle taken that kind of path, that is OP plus PQ. So that is the reason why in terms of vector notation we can write OP bar plus PQ bar equal to OQ bar. That is OP bar plus PQ bar equal to OQ bar. Okay. OP bar plus PQ bar equal to OQ bar. How? Why to take like that means here particle has taken path like that, OP plus PQ, finally reached Q. If at all it takes that path from O to Q also, it can reach Q. That is the reason why in vector notation OP bar plus PQ bar equal to OQ bar. What is OP bar here? OP bar means R1 bar, that is R1 bar. What is PQ bar here? PQ bar means S bar. Okay. Now what is OQ bar here? OQ bar means R2 bar. So OQ bar means R2 bar. So replace OP bar means R1 bar plus PQ bar means S bar is equal to OQ bar means R2 bar. Okay. R1 bar plus S bar equal to R2 bar. R1 bar plus S bar equal to R2 bar. Okay. Coming to S bar, make it subject S bar. S bar equal to R2 bar minus R1 bar. Displacement vector S bar means PQ bar, that is PQ bar equal to S bar equal to R2 bar minus R1 bar. So S bar equal to R2 bar. What is R2 bar? X to I plus Y to J plus Z to K. X to I plus Y to J plus Z to K minus, what is R1 bar? R1 bar means X1 into I plus Y1 into J plus Z1 into K. So X1 into I plus Y1 into J plus Z1 into K. That is S bar equal to subtraction of vectors here. This is one vector, this is another vector. Here one vector minus another vector. That is x2 minus, here negative sign is there, no. That is why x2 minus x1 into I cap. x2 minus x1 into I cap plus y2 minus y1 into y2 minus y1 into j cap plus z2 minus z1 into k cap. So this is what displacement vector, when it is displaced from position P to another position Q with the position coordinates x1, y1, z1 to x2, y2, z2. So x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. This is what displacement vector for that particle when it is displaced from position P to position Q. Okay. Now what is the direct distance between P and Q? How to get that distance between P and Q means by taking modulus, magnitude, modulus, that is mod S bar equal to root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is what the distance between P and Q. The distance between P and Q. Obviously, it is nothing but a mathematical expression. Okay, making use of the which we can determine the distance between 2 points. Why? Because here P is there. P x1, y1, z1. Here Q is there. x2, y2, z2. Now, how to find distance between these 2 points? By making use of mathematical expression. What is that expression? Root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So simply this is also same. So root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. Suppose here position P is fixed to origin, for example. If I fix position P to the origin with coordinates 0, 0, 0 and coming to Q, x, y, z. What happens? Let us see. Let us see. Suppose position P, suppose position P is to be taken as origin, for example 0, 0, 0. Okay, I am fixing P to the origin. Origin means reference point. That is the reason why I am taking 0, 0, 0 instead of x1, y1, z1. Now what about Q? Let Q be the particle. Let Q be the particle. Here Q. As P becomes 0, 0, 0, I am taking Q as x, y, z. X, y, z. Now, whenever P is taken as origin, a directed line segment drawn from origin to the position of the particle, nothing but the position vector. Same is displacement vector in the previous case. Now, that itself position vector means position vector and displacement vector sometimes one and the same. Okay, in previous case, PQ bar is nothing but S bar. Now, PQ bar is nothing but position vector. So R bar equal to S bar in this case. R bar equal to S bar. Why it is R bar? Why? Because here P is reference point, fixed reference point. Why? Because coordinates are taken as 0, 0, 0. With respect to which we are going to determine position vector of Q, particle Q. whose coordinates are x, y, z with reference to fixed origin. That is the reason why your position vector itself displacement vector. Okay. Now r bar is equal to s bar is equal to, now x minus 0 into I cap, that is xi cap, plus y minus 0 into j cap, that is yj cap, plus z minus 0 into k cap, that is zk cap. So r bar equal to s bar equal to xi cap plus yj cap plus zk cap. Now coming to modulus. If we take modulus, mod s bar is equal to root over what is the modulus here? X2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Here x1 y1 z1 x2 y2 z2. So x2 minus x1 means x minus 0, x minus 0 whole square, square root of x minus 0 whole square plus y2 minus y1 whole square, y2 minus y1 whole square means y minus 0 whole square, y minus 0 whole square plus z2 minus z1 whole square means z minus 0 whole square, z minus 0 whole square. Simply we are replacing. Okay. Here x1 y1 z1 means 0 0 0, x2 y2 z2 means x y z. So making use of this expression, we can find the magnitude of displacement vector or position vector in this case. What is that case? T is taken as origin and Q as the particle with coordinates x, y, z. Now in that case, r bar itself displacement vector. So mod s bar equal root over x minus 0 square plus y minus 0 square plus z minus 0 square. That is root over x square plus y square plus z square. Root over x square plus y square plus z square. Nothing but magnitude of vector. Magnitude of that vector s bar or r bar. Okay. So how to find magnitude? Square root of x component square plus y component square plus z component square. X component, here x component x, y component y and z component z. So root over x square plus y square plus z square. Okay. Right. Next, a small numerical. Suppose r bar equal to 2i cap minus 3j cap plus 5k cap plus 5k cap. This is what position vector of any particle at some other instant. Right? Now find mod r bar means magnitude of position vector and r cap, unit vector of that r bar. R cap means unit vector, mod r bar means magnitude of that position vector. Now what is the solution? R bar equal to 2i. Here minus 3j means plus 3 into minus j cap plus 5k cap. So here 2 is the x, 3 is the y and 5 is the z. So what is x coordinate? 2. What is the y coordinate? 3. In fact that is 3, not minus 3. Why? Because magnitude always positive. So 3 into minus j cap means what is the coordinate? Y coordinate 3. Here z coordinate 5. So mod r bar means what is the expression? Mod r bar root over x square plus y square plus z square. Root over x square plus y square plus z square. That is root over x square means 2 square plus y square means 3 square plus z square means 5 square. That is 4 plus 9 plus 25. 25 plus 9. means 34. 34 plus 4, root over 38. Root over 38. This is the magnitude of given position vector. Coming to unit vector of that position vector. How to find unit vector? As I told you, r cap always equal to r bar by modulus of r bar. So any vector divided by its magnitude gives unit vector of that vector. So r cap equal to r bar by mod r bar. That is, r bar means, what is r bar? 2i minus 3j or plus 3 of minus j plus 5k divided by mod r bar root 38. So this is what unit vector of given position vector. So here magnitude 38 units and position unit vector 2i minus 3j plus 5k by root 38. Coming to next numerical. Suppose a cap equal to 0.2i cap plus yj cap plus 0.4k cap. Okay, this is what given unit vector 0.2i cap plus yj cap plus 0.4k cap is a unit vector. If a bar is a cap is so and so, is a unit vector, find y coordinate. What is the y coordinate? So here x component is given. What is that x component? 0.2. Z component also given 0.4. Coming to y component, unknown. How to find that unknown coordinate means very simple. In data, it is clear that a cap is unit vector. Unit vector in the sense magnitude is 1 unit. So we can find its magnitude and can equate it to 1. So mod a cap equal to root over x square plus y square plus z square. This is what magnitude. Root over x square plus y square plus z square. So mod a cap equal root over x square plus y square plus z square. Here x means 0.2, y means y only unknown, z means 0.4. So root over x square means 0.2 whole square plus y square means y square only, z square means 0.4 whole square. Now what about mod a cap? From data it is given that mod a cap is 1 unit. Why? Because that is unit vector. So mod a cap means 1. And squaring both sides, 1 equal to 0.2 whole square means 0.04 plus y square plus 0.4 whole square, that is 0.16. Okay, that is 1 equal to 0.04 plus 0.16, that is 10 to point. So 0.2 plus y square. 1 minus 0.2 means 0.8 equal to y square. 1 minus 0.2 equal to 0.8, that equal y square. Y equal to root over 0.8. So this is what unknown quantity in that vector. What is that unknown quantity? Y coordinate. So what is y coordinate? 0.8. Okay. So what is the ultimate given unit vector means a cap equal to 0.2i cap plus root over 0.8 j cap plus 0.4 k cap. So this is the given unit vector in fact. Okay. So what we learned here means, suppose r bar equal to xi plus yj plus zk. This is the given form of vector. R bar means any vector. Okay, r bar equal to xi plus yj plus zk. Now, this vector finds different lengths in different directions. Okay. Similarly, it finds different lengths in different planes also. Planes means xy plane or yz plane or zx plane. So, let us see. Mod r cap along x means x. What is this mod r bar means? Modulus means magnitude or length or projection or scalar component. Mod r bar means. Here suffix x means the length of that vector along x-axis. What is that length? X units. Mod r bar along y means y units. Mod r bar along z means z units. So we can write xyz means, what is xyz here? Scalar component or magnitude or length or projections. These many names are there for modulus. What are the names here? Scalar component or magnitude or length or projection along x, y, z axis respectively. What is that? Mod r bar along x means length of that vector along x means x units. Mod r bar suffix y means length of that r bar along y axis means y units. Mod r bar suffix z means length of that given vector r bar along z axis. So x, y, z means scalar component or magnitude or length or projection along x, y, z axis respectively. Now same can be written as mod r bar xy. What is xy here? Plane. Xy plane. So same vector finds different lengths in different planes. No. That is the reason why mod r bar in xy plane means root over x square plus y square. Root over x square plus y square gives length of r bar in xy plane. Similarly, mod r bar suffix yz means root over y square plus z square. Y square plus z square. Here z component 0, here x component 0. Here xy plane means root over x square plus y square. Take x and y coordinates. Here yz plane means take y coordinate and z coordinate. Leave off x coordinate. Okay. Similarly, mod r bar zx plane. Length of r bar in zx plane means root over z square plus x square. So what is this formulas means? Again, scalar component or magnitude or length or projection along projection, not along planes, projection in xy or yz or zx planes. Okay. Any vector, if you are given three-dimensional vector, suppose a three-dimensional vector, it finds different lengths in different directions. Okay. Also finds different lengths in different planes also. These are the lengths of same vector along x, y and z axis respectively. These are the lengths of same vector in different planes. What are the planes? This is in xy plane, this is in yz plane, this is in zx plane. So same vector finds different lengths in different planes. Let us see with one small example. Suppose one small example. r bar or s bar, whatever it is, s bar equal to 2i cap plus 3j cap plus 4k cap. This is a given vector. Suppose this is the displacement vector of any given particle. Okay. Now, mod s bar along x. Mod s bar means magnitude, otherwise length, otherwise projection, otherwise scalar component, whatever it is. But especially along x. Why? Because suffix x only taken. So s bar suffix x means, mod s bar suffix x means take x component, that's all. So x component, what is x? Here x equal to 2, here y equal to 3, here z equal to 4. So mod s bar suffix x means x ohm, that is 2. Mod s bar suffix y means y coordinate only, that is 3. Mod s bar suffix z means z coordinate only. What is z coordinate? 4. Okay, 4. Now mod s bar suffix xy means length of that vector in xy plane, means root over x square plus y square. That is root over x square plus y square means 2 square plus 3 square. 2 square plus 3 square, that is 4 plus 9, root 13. Coming to mod s bar suffix yz means length of that vector or magnitude of that vector in yz plane given by root over y square plus z square, that is equal to root over y square 3 square plus 4 square, 3 square plus 4 square, that is 9 plus 16 and a root 25 means 5. Coming to s bar suffix zx, length of given vector in zx plane means root over, how to find? Root over z square plus x square, that is root over z square, z means 4, x means 2, so 4 square plus 2 square, that is 16 plus 4 and a root, that is root 20. Root 20. Same can be visualized as follows by drawing one parallelepiped. Okay. Again I am taking coordinate axis x, y and z. So this is x axis, this is y axis, this is z axis. Okay. What is the length of this vector along x means 2. Suppose this is O along x. This is O to A 2 meters for example. Parallel to y. Parallel to y means 3 meters. That is parallel to y 3 meters. Okay. Parallel to z means 4 meters. Parallel to z means here OZ. Z is here. So from this position, take one more vector parallel to z. Parallel to z. Okay. 4 meters. 4 meters. Suppose in this sum, it is given that a particle starts from origin and covers 2 meters along x axis, and again 3 meters parallel to y axis, and finally 4 meters parallel to z axis. That is the given data for example. Okay, 2 meters is along x, 3 meters is parallel to y axis, and 4 meters is also parallel to z axis. So along x, parallel to y and parallel to z. So 2 meters, 3 meters, 4 meters. That is the given data as an example. Okay. Now draw one line here. Now one more line parallel to z. Parallel to z. Now one more line parallel to this line. So we have parallelepiped here. Parallelepiped. Okay. Parallelepiped. So OA bar. OA bar means 2I cap. Let it be S1. S1 bar. This is what B, this is what C, this is what D as an example. So OA bar means S1 bar, that is 2I cap. AB bar means S2 bar, S2 bar, that is 3J cap. And BC bar means 4K cap, that is S3 bar, S3 bar. So S1 bar, S2 bar, S3 bar. And finally OC means, what is OC? Here OC means final vector, that is S bar. S bar. Here S bar. Here S bar is a combination of 3 vectors. What are the vectors? 2I cap is one vector, 3J cap is another vector, and finally 4K cap also one more vector. So because of combination of these 3 vectors, here S bar is formed. So S bar equal to 2I plus 3J plus 4K. So S bar equal to 2I cap plus 3J cap plus 4J cap. That is how S bar is formed. Okay. Right. Here particle has taken a path like that, OA, O to A, again A to B, and again B to C. Ultimately, it reaches position C. It reaches position C. So what is the path followed by the particle? O to A to B, and B to C. Finally reaches C. If at all, it takes a direct path from O to C also, it could reach C only. That is the reason why what I am saying means S bar equal to S1 bar plus S2 bar plus S3 bar. Okay. S bar equal to S1 bar plus S2 bar plus S3 bar. Right. So S bar equal to S1 bar plus S2 bar plus S3 bar. That is S1 bar means 2 into I cap. 2 into I cap. Why? Because what is the unit vector along x-axis? I cap. So magnitude multiplied by direction to get vector. So 2 into I cap plus what is S2? 3 into J cap. 3 into J cap plus what is S3? S3 means 4 into K cap. Why? Because K cap is the unit vector along Z axis. So 4 into K cap. So this is what given vector. How? That is how given vector is formed by the combination of 3 individual vectors, 2I cap plus 3J cap plus 4K cap. Okay. Now, how can you assign the length of this vector in XY plane, YZ plane and ZX plane? Let us see. This vector finds a length of 2 meters along X. Here S bar finds, what is the total vector here? S bar. Here S bar finds 2 meters along X axis. Okay, and 3 meters parallel to Y axis and 4 meters parallel to Z axis. So given vector S bar finds different lengths in different directions. That is 2 meters along X, 3 meters parallel to Y and 4 meters parallel to Z. Okay. Now this vector finds different lengths in different planes. No. Let us see. Plane means XY plane. Where is XY plane? This is what X, this is what Y. So this is what XY plane. Okay. So this vector S bar finds a length of root 13 meters in XY plane. How to locate that modulus of XY bar means here. This is what modulus of XY bar. Let us see. Let us see. Along X that is 2 meters, parallel to Y 3 meters. Now this hypotenuse side gives length of this S bar in XY plane. Okay. See, this is what mod S bar along XY plane, in XY plane. In XY plane. Mod S bar. See, this is what length of this S bar in XY plane. This hypotenuse in this triangle, the hypotenuse side becomes length of S bar in XY plane. Okay. Now coming to YZ plane. Where is Y? This is Y. This is Z. Means this is YZ plane. Otherwise, this side also, this box also means this plane also YZ plane. this is yz plane, otherwise this is yz plane. So here y coordinate 3, z coordinate 4, right? Now what is the length of S bar in yz plane? Means from this bottom end to top end, diagonal side, means diagonal side from A to C. In this plane, this diagonal side becomes equal to length of S bar in yz plane. Okay, here O, here A, here B, here A, here it is B, here it is C. Okay, this is diagonal side. In this plane, diagonal AC becomes length of S bar in yz plane. What is that measurement? 5. So mod S bar yz in yz plane. Coming to one more component, that is length of S bar in ZX plane. ZX. Where is X? Here it is X, 2 meters for example. What about Z? 4 meters. So here 2 meters, points O to A. So O to A means 2 meters. Now Z coordinate 4 meters. The Z coordinate is somewhat high over OA. Now shift this vector until it touches ZX plane. See, this is X, this is Z. ZX plane means this is what ZX plane. Now shift this vector until it touches ZX plane. Means here, like. So O, A. Now what about this point? This point means it's not C. That is D. Why? Because this vector is shifted down to touch ZX plane. It should touch ZX plane. Then only we can add these two vectors. So it's not C. In fact, this is D. Now, what about the length of S bar in ZX plane? Means from O to D. It's not O to C. If it is from O to C means total length of vector. Total length of vector means mod S bar. That is mod S bar means a distance from O to C. That becomes total length of vector. But here length of that vector in ZX plane. ZX plane means here X axis, here it is Z axis. ZX plane means this bottom plane. In that bottom plane, OA is lying in that plane only, but S3 lying somewhat high. That is the reason why that is to be shifted to touch ZX plane. Means shifted down. So OA, AD. Now draw one line segment from O to D. Means O to D, not from O to C. This is O to D means bottom end to bottom end. This is what mod S bar in ZX plane. Length of S bar in ZX plane. Here it is length of S bar in YZ plane. Here it is length of S bar in XY plane. See, length of S bar in XY plane means this bottom end to top end. Means hypotenuse side here in this plane, hypotenuse side. Now, what is the length of it? This S bar in YZ plane means from this bottom end to top end. Means again diagonal side. Here also diagonal side, here also diagonal side. From bottom to top end. Now, what is the length of that given vector in ZX plane? Means from this bottom end to bottom end. That is from O to D only, not from O to C. In fact, OC lying three dimensional, X, Y, Z means lying like that. Okay. So that's about magnitude of given vector in different directions and different planes. Okay. Thank you friends. If you are really interested with my video, please like my video, share my video, comment on my video, and please don't forget to subscribe my channel. Okay, thank you.